Right now, joining in the 2021 A-level structure essay number 2, the inorganic question. So this question contains part A, part B, and a small part C, and also a part D. Very small part C actually, and then somewhat little bit complex part D is there. Right. So look at this part A. A is an S block element. It has atomic number less than 20. Again, less than 20 means no calcium involved. So it reacts with water vigorously with ignition. Vigorously with ignition, you can say that it's potassium directly. We have given it in the class to give a strongly basic solution with the evolution of a gas. A reacts with excess oxygen to give the superoxide. So potassium gives the superoxide, right? And then rubidium and cesium will also give the superoxide. So all the oxide, peroxide, and then superoxide will be formed by these three elements: potassium, rubidium, and cesium. So the naturally occurring O sylvite contains the compound A. Now knowing this is optional. Like if you know it, then fine. But they have just told it that there are potassium in sylvite, right? So write the chemical symbol of A. Write the chemical symbol of A. A is going to be potassium. A is going to be potassium. Write the complete electronic configuration. You can write that. That's easy. Then the gas evolved in the reaction of A with water, right? That's the hydrogen gas, right? That's hydrogen gas. And fourth one, what is the color given by A in the flame test? So potassium gives lilac color. Potassium gives lilac color. And then write the balanced chemical equation with the reaction of A with excess oxygen. So potassium reacts with oxygen excessly to form potassium superoxide, KO2. Sixth one, is the first ionization energy of A higher or lower than that of the element in the same group and the period above it in the periodic table? Explain your answer. Now they're asking element above it. That means they are comparing with sodium. So they're asking, is sodium's ionization energy higher or lower? So actually sodium's ionization energy is actually larger than potassium, right? So the reason for that is the effective nuclear attraction of the what do you call sodium is larger than potassium, because potassium has an extra electron shell around it, right? It has an extra electron shell around it. If you write the answer there, lower, and then write the explanation for it. When going down the group, effective nuclear attraction is decreasing, the atomic size increases, and the attraction to the outer electron to nucleus decreases. You can check the marking scheme for this, and then you can write that. It's a easy one. This is not related to inorganic actually. This is coming in unit 2. So ionization energy variation. Give the chemical formula of the compound A in sylvite. Right. In sylvite, there is KCl. Right. There is KCl in sylvite. Right. Then we go for the part B. B is an anion containing only the two elements X and Y in the ratio of 2:3. Both X and Y are P block elements that belong to the same group of the periodic table. The atomic number of each element is less than 20. Okay. Okay, fine. Then the electronegativity of X is less than that of the electronegativity of Y. When X reacts with hot concentrated sulfuric acid, a colorless gas with a pungent smell, is evolved as one of the products. Right. Right. Then X is going to be sulfur, and then Y is going to be oxygen. So from the electronegativity also we can think the anion ratio, and it's 2:3. So we can tell that this is S2O3 2 minus. You can get that X is sulfur because, from this statement, under reactions of H2SO4, concentrated H2SO4, there is sulfur. You can check the note. So from that point, you can get into this question. So S2O3 2 minus is the anion. Draw the Lewis dot dash structure for the B. That one you can. Give the oxidation number of the central atom of B. Okay, in order to tell that. So S2O3 2 minus. looks something like this. And the central atom oxidation number we can mark plus, 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 and plus. So here 0 and 0. So when you circle this, the oxidation number of the central sulfur atom is plus 4. You can easily write that. Then give a chemical test to identify B, right? Give a chemical test to identify B. So B is going to be B not the compound. It's the anion. Yes, it's the anion. So you can write anything given in your note. For example, you can write addition of lead nitrate, right? Addition of lead nitrate, and which will give a white color compound, and you heat decompose it to form lead sulfide. It's like this. You add this one into this, and then you get lead thiosulfate. Lead thiosulfate you heat decompose to form lead sulfide. So you can write that if you want, or else AgNO3 addition, right? Silver nitrate addition, you will get Ag2S2O3, which turns black on standing. That point you can write. Also, you can add addition of dilute acid, which evolves a gas, right? Which evolves a gas. You can write those things here. Observations are also required. So there are many things you can write there, right? So addition of dilute H2SO for observation giving a colorless gas with a pungent smell and a colloidal sulfur precipitate or a milky solution. Like this, you have to write the test and then the observation. That's it. Right. Then fifth one, write the chemical formula for the compound which has A as the cation and B as the anion. Right now, A is going to be potassium and B is S2O3 2 minus. So there you go, K2S2O3. K2S2O3 is the compound. C is an oxidizing agent. Now, again, there's a new compound called C. It is composed of 3 elements in the ratio 1:1:3. Oxidizing agent. One of the elements of C is A. Okay, one of the elements of C is A. Now that's potassium low. Okay, other two elements belong to P block of the periodic table. So one of this is potassium. So one of this is potassium. It can be the first one, right? So one of these two elements is present in B. Okay, in B, one of these are there. It can be oxygen or sulfur. It can be oxygen or sulfur. They haven't told. The salt formed between Ag plus and the anion of these elements is yellow in color. Okay. And insoluble in concentrated ammonia solution. Now you have to get the idea that this is AgI. Yellow in color after addition of Ag plus. Formation of AgI should be there. Formation of AgI කියන්නේ iodine should be there in one of these, right? So there is potassium, there is sulfur oxygen, and there is iodine, right? There is iodine. So the best answer that you can go here is KiO3, right? The best answer you can go here is KiO3 with the ratio KiO3, right? It can't be sulfur because Ki is 3. That I know, like, you haven't heard of such thing. So the best answer you can go is KiO3, which is a standard compound. Write the chemical formula of C. So KiO3 you can write there. Then part D. D is a compound composed of 2 elements. Both these elements are also present in C. Okay, now there are 2 elements in D. Both these elements are present in C. Okay, right? When C is mixed with excess of D in acidic medium, reddish brown solution is obtained. Okay, now this reaction is very specific, and almost all years they are going to give you this reaction. I minus and IO3 minus and I minus reacts together to form I2. They are talking about this reaction. When you balance this reaction, you will get H plus on the left hand side, right? So something like this. I'm not going to balance this right now. You can balance this and take. So this is what they're talking about. IO3 minus reacting with I minus to form I2. So I minus is actually Ki, which is Ki. You can write here, identify D, that's going to be Ki, right? So reddish brown solution can I2, right? Reddish brown solution can I2. Then second one, write the balanced ionic equation for the reaction that takes place. So you can write that this reaction they are talking about, you can balance it and write. Then second Roman number on the addition of excess of solution containing B to the reddish brown solution obtained, the reddish brown solution became colorless. When you add B, it becomes colorless, low. So you know this reaction, I2 plus S2O3 2 minus, right? This is the iodometric titration reaction. Forms S4O6 2 minus plus I minus. So forms 2I minus. Then third Roman number, concentration of solution containing B can be determined by volumetric analysis utilizing the reactions 1 and 2 above. Okay, this is the iodometric titration which I was talking about. So indicator used here is torch, and the color change is going from black blue color. When you add starch, it's going to go to black blue color, and then when the iodine is completely over, it's going to go to colorless. Go to colorless. There you go. So with that, the 2021 inorganic structure essay question is done.